So measuring center. How long do people typically spend traveling to work? The answer may depend on where they live. Here are the travel times in minutes of 20 randomly chosen workers in New York State, along with a dot plot of the data. So we have all this data listed, and we made a dot plot so that we can see it a little bit better. And one measure that people like to use when they talk about mean and median, they also like to talk about mode. Mean, median, mode. Mean, median, mode. That's what you heard when you were in elementary school and middle school. The mode is a thing. It is where the data occurs most often, but it's not a good measure of center because it can really occur anywhere. So if the lowest number happens the most, that's where the mode's going to be. So I don't want to use mode as a measure of center. So we could report the value of the middle of a distribution as its center, and so that is the median. The median is the middle value. So median is the midpoint. I'll try to underline what the lines are. The median is the midpoint of the distribution. It's the number such that about half of the observations are smaller and about half are larger. So the median cuts the data literally in half. There you go. Median's going to cut the data literally in half. Half of the values are going to be above it. Half of the values are going to be below it. Okay? To find the median, you guys know how to find the median, right? The first thing you have to do is arrange the values from smallest to largest. So you do have to put the data in order, okay? You do have to put the data in order first. Now, if the number n, that's your sample size, if the number n of data values is odd, so you have 13 data values or 15 data values, then the median is the middle value. It is literally going to be a single middle value. So if you're like marking off the highest, lowest, highest, lowest, highest, lowest, highest, lowest, you'll find the actual middle value. But if your number of values is even, if you have an even number of data, then you're going to have to use the average of the two middle values in the ordered list as the median. You guys, again, have probably done this for a lot of times in your life. So, median. Cool? So, the median's pretty easy to find by hand. We don't have to really do anything fancy. So, the median's pretty easy to find by hand for a small set of data. The only problem with a large set of data is putting all those numbers in order. It's just time consuming. So here's the amount of fat in grams of 9 different fish and chicken sandwiches on McDonald's menu. So we have anywhere from 6 grams of fat all the way up to 40 grams of fat. What sandwich do you guys think that is? It's the Big Mac. Yep, there it is. So we need to find the median. So what do we need to do first? Put the data in order. So what's our lowest number? 6, okay? And then what's our next number? Okay, we got a 17, good. And then 19, and then 20, and then 21, and then 22, and 26, 28, and 40. Nice. All right. Now we just got to find the middle number, okay? So I just literally mark off the top and bottom each time. So top or bottom, top, bottom, top, bottom, top, bottom, top, and boom. I found my median. Do you guys have any questions on finding the median? Easy. Yes?
If it was odd, would you have to add up all the numbers to see if it was odd?
So when we're talking about an odd number of observations, so meaning this is 1, 2, 3, 4, 5, 6, 7, 8, 9. We had 9 observations in this data set, so we had an exact median and an exact middle. so we didn't have to worry about that. All right, so what is the interpretation for the median? Blah, 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 go ahead. We already did that. Thank you very much. So here's the interpretation for the median. It's literally exactly what you would think it is. About half of McDonald's fish and chicken sandwiches have more than 21 grams of fat, and about half have less. There's your interpretation. So we found our median. It was this little number right here, and about half have less than that, and about half have more than that. So now we're going to go back to our original problem from the beginning, which was how long it takes to get to work in New York. This time we weren't given the numbers, we were given a dot plot. And so we want to find and interpret the median of this dot plot. So again, you can just kind of mark off the highest, lowest. So low, high, low, high, low, high, low, high, low, high, high. Okay, low, high. Okay, so now I'm down to 2. So I have 2 that are in the middle. So there was an even number of values in this particular data set, and there's 20. And so I have 2 numbers in the middle. So how do I get the median?
You add them together and divide by 2.
Yeah, I just average them, add them together, divide by 2. So this is 20 and 22, 20 and 25, that's what that is. So I'm going to add 20 and 25 and divide by 2, and that'll give me the median. Or you can just think about what's in the middle of 20 and 25. 22.5. So there's my middle. 22.5. And how do I interpret that?
About half of the workers got to work in less than 22.5 minutes.
Perfect. So about half of about half of the sample take less than 22 and a half minutes to get to work, and about half take more than 22 and a half minutes to get to work. Exactly. So here's our answer. I actually sorted them. That's whatever. Okay, so there's our interpretation right there. About half of the workers in the sample travel less than 22 and a half minutes to work, and about half travel more. So that's the idea of median. Uh-oh. About half are less than 22.5 minutes, and about half are more. All right, now we're going to transition and talk about the other one, the other measure of center. What's the other measure of center? Mean. So we're going to talk about the mean. Do you guys know how to find the mean? I mean, we just found a mean, right? We just found the mean of 2 numbers. So the mean of a distribution of quantitative data is the average of all of the individual data values. To find the mean, you're going to add all of the values and divide by the total number of data values. You guys knew that, right? Yeah, you know how to do this. Now, I'm going to show you the statistical formula, because you guys are in a stats class. I'm going to show you the statistical formula for mean, And it's going to look a little scary, but you guys already know how to do it. You've been doing it since elementary school, okay? So don't let the fact that there's this fancy looking formula make you go like, oh my gosh, I can't do this. Yes, you can. You already know how to do this. So it does look very fancy, but here it is. So the notation for mean is X bar. The notation for a mean is X bar. It's literally an X with a line over the top of it. That's how you notate that you have a mean. It's X bar. And what you do, again, you've already told me in words how to do this. You take the sum of the data values and you divide by the number of data values. That's what you do in words. This is the mathematical notation for what you're doing. You're taking the first x, or the first variable, plus the second variable, plus the third variable, all the way up to however many number of variables you have, and you're dividing by that n, that sample size. And if I squish that down even further, then I can use this symbol. This symbol is capital sigma, and it means to sum. It means to take the sum of. So that's a sigma, and it just literally means to take the sum, and then you take the sum of whatever's after it. And right here it says x sub I, x with a little I in the subscript. That just means your x values. That's all that means. It just means your x values. And then this n is your sample size. So again, all we did was we just took what you know about finding mean and turned it into symbols. That's it. So I didn't change anything on you, I promise. You're still just finding the mean. It just looks fancier now. Okay? We're fancifying things. Do you guys have any questions about mean, how to do it? All right, let's give it a try then. Let's go. So, how many runs does the McKinney-Boyd High School baseball team usually score? Here are data on the number of runs scored by the team in all 21 games played during a recent season, along with a dot plot. So the numbers are in order, which is kind of nice, and we've got a dot plot here. We're going to calculate the mean number of runs scored per game by the team during this season, and then the dot plot suggests that the game in which the team scored 12 runs is a possible outlier. It's pretty far up there. Calculate the mean number of runs scored per game by the team in the other 20 games this season, and what did we notice? So we're going to do both of those real quick. So to find the mean, I need to add all these numbers up. I need to add all those numbers up, and then I would divide by the number of numbers, which it tells us there's 21 in this sample. So we're going to add all those numbers up and then divide by 21. So you can go ahead and do that. All right, when you added, so you summed all the x's. When you added up all the values, what did you get? What'd you get? 87? Is that?
When you added them all up and then it divides out to 4.1.
Okay, so we get 87, and then we divided by the sample size, which was 21, and we actually get 4.14. Okay, so that's the average. So again, that is the mean number. So that basically means that we can expect to see about 4 runs scored per game. That's what that means. Now we're going to re-average it, but we're going to re-average it without the 12. Now, does that mean you have to re-add up all the numbers? Not necessarily. What would be a faster way with the fact that you know the sum of all the numbers? There we go. So, if I take the 87 and I subtract the 12 out of it, take the 12 out of the 87, then what would I divide by? I would divide by 20 instead of the 21. And so 87, I take away the 12, and then I divide by 20. What does the new mean?
3.75.
Very good. 3.75. Perfect. Now, the question, part B here, is asking you is, what do you notice? What happened when we took the 12 out? Did the mean change?
Yes.
Yeah, what happened to it?
It got removed.
It decreased, okay? So, removing a high outlier made the mean decrease. So that's what happened. I took out a possible upper outlier and the mean went down. And so what do you guys think would happen if we took out the 0? What would happen to the mean? Which way would it go?
It would go left.
It would go up, okay? So whichever side I'm taking away of an outlying value, the mean's going to go in the opposite way, right? So the mean doesn't have to account for the 0, so it's actually going to be a little bit higher now. The mean doesn't have to account for the 12, so it's actually going to be a little bit lower now, okay? So depending on which side you take numbers off of or add numbers to will depend on which way the mean goes, okay? That illustrates an important thing about the mean. So the mean is said to be resistant. Not resistant. Sorry. This phone is distracting me. This Miss Lakey. Uh-huh. Okay, she's not in class today, but yeah. Yeah. Yep. Thanks. Bye. All right. So the mean is not resistant, meaning that the mean can't help itself to change, right? Resistance means like you don't want to move, right? You are resisting something. So the mean is not resistant. It is going to probably change if the values are changing. So here's the definition of resistance. A measure of center. Now this also is going to be true for measures of spread. So a measure of center or spread is resistant if it is not influenced much by extreme value changes. So the mean is not resistant. It can't help itself. But the median is resistant. The median is resistant. So in that previous example with the McKinney Boyd High School baseball team, we had 21 game season. The median was 3, okay? Now, if I take off that 12, then that means that my median now is the average of these two numbers. And so what's the median? It'd still be 3. Yeah. Because the average of 3 and 3 is 3. Yeah. So if I take off that 12, then yeah, my average is now a 3, which is the same as it was before. So in that situation, that shows you that the median doesn't really change as much when you have extreme value changes. The mean is going to change. So the mean is not resistant, but the median is resistant and it's resisting any changes. Okay? Any questions about any of that so far? All right, so we're going to do this quick little activity with the mean as a balance point. Huh?
I have a question.
Oh, yeah, I'm sorry.
It was about the first, the run score question that we did.
Okay, which part of it?
It was when we took off the 12.
Uh-huh.
I think, I forgot the question. If there were 2 dots on the 12, would you put 19 instead of 20? Because 75 is being divided by 20.
Are you talking about when we found the mean?
Yeah.
So if there were 2 dots on the 12,
Mm-hmm.
so that would be like that.
Mm-hmm.
And so we'd have that.
Mm-hmm.
And so there would have been 22 observations, right?
Mm-hmm.
So then the are you talking about the mean? The mean would then have been, we would have had to add up all those numbers and we would have divided by 22.
Okay.
Uh-huh.
Okay.
Yep.
Did you take off both 12s or just the one?
Well, if it told us to take off, so it told us to just take off the 112, but I mean, if it told us to take them both off, we would take them both off. It just depends on what the problem's asking you to do. Mm-hmm. Yep. All right, so we're gonna do this little balancing thing. I'm gonna give you guys a ruler and 5 pennies, and you're going to go through this little mean as a balancing point and try to figure out what's happening here. All right? Yes. Yes. This one's not working?
No. There's tape on it everywhere.
Oh,
And there's holes
yes.
in it.
The tape is definitely going to be a problem. So try to get it to balance. See if you can get that ruler to balance
I think I did it.
with your 5 pennies stacked at the 6-inch mark. Nice. You got that other pencil underneath it? No, I'm just kidding.
You didn't give us pennies.
Oh, I didn't give you guys pennies? How are you supposed to do that? There you go. Oh, you have it balanced? Can you keep it balanced with the pennies? All right, so we've got our 5 pennies balanced. And it says here we've got all 5 pennies at the 6. And hopefully you are able to get your ruler to balance. What is the relationship between the location of the pencil and the mean of the 5 pennies that are all at the 6 mark? So what is the relationship between the location of the pencil and the mean of these 5 pennies? Basically the question being, what is the mean of 6, 6, 6, 6, 6? It's 6, right? So it appears that our ruler, the pencil shows us where the mean is for those pennies. So here's what you're going to do now. You're going to take 1 penny off of the stack and put it at the 8-inch mark on your ruler. Now take another penny and figure out where you have to put that one to balance the ruler again. Leave the other 3 pennies at the 6-inch mark. Okay, you got, oh, look, yours is perfect. Wow. All right. Where did you have to put the pennies, where'd you have to put that 1 penny in order to balance it when you have 1 at the 8 and the other 3 at the 6?
4.
You had to put it at 4, okay? So what is the mean of the 5 numbers now?
6.
Still 6, right? So I still have a mean of 6 because that's where my pencil is. The pencil is where the mean is, okay? So the mean is still 6 because that's where my pencil is. Now, move one more penny off the stack to the 2-inch mark. Leave your other ones at 8 and 4, but put a penny at the 2-inch mark. Now take both of the remaining pennies from the middle and move them somewhere to rebalance your ruler. Move them anywhere to rebalance the ruler. You can move them somewhere together. You can move them somewhere separately. But you're trying to rebalance the ruler. So you should have one at 8 and 4. And now you have one at 2. And you're trying to rebalance the ruler with the other 2 pennies. Two, 4, 6, 8, and 10 and a half. That ruler must be unbalanced. Cool. Where's your pencil at? Is it still at 6?
Yeah, it's pretty much at 6.
Pretty much at 6? Okay. Does anyone have their pennies somewhere other than 2, 4, 6, 8, and 10 and a half-ish? No? Okay. So when you do that, you can kind of tell. Now, what would happen if you moved your pencil to the 5-inch mark? Move the pencil or the ruler, it doesn't matter. Move that to the 5-inch mark and see if you can get your ruler to balance. Yes, yeah. Yep. Move your ruler to the 5-inch mark and see if you can rebalance your pennies. Anybody able to do it? Where did you put your pennies?
0.5, 2, 4, 5 and a half, 6 and a half.
Okay, and what do you think the mean is? What do you think the average would be?
4.
It's wherever your pencil is. Yeah, it's pretty close to where your pencil is. So the average is where the pencil's at. Have y'all been able to balance back there?
I couldn't get my ruler balanced.
You must.
These just were a disaster.
Oh my gosh.
I gave up like 5 minutes ago.
Oh my, you just gave up. You
I
said
just
no.
tried.
You said forget
They
this.
wouldn't even balance, and then the pennies would just. It was
It's too much.
so early in the morning.
Too much. Okay, got it. Good to know. Anybody else able to get your pennies to balance with your pencil at 5? What do you notice about the spacing of your pennies when your pencil's at 5? They're not even. No. And probably you have more pennies on one side than the other. Okay? So what that means is you have a skewed distribution. Oh my gosh. Now we have skewed distributions. So all of this to say, why do you guys think the mean is called the balance point of the distribution? If we kind of think about our graphs as like sitting on top of our ruler or whatever, like the mean is where we could balance that, right? It's where our graph would balance. So the mean is called the balance point of a distribution because the mean is where the data balances. So again, if you think about putting a graph on like one of those little triangular little fulcrums, and you think about how can I get this thing to balance, that is what it is. So there's a picture of this here at the bottom of this page. This is that data on the runs scored in each game by the McKinney Boyd High School baseball team. And we found the mean of 4.14. I'm going to make this bigger just so you can see it better. That is where this distribution would balance. So the mean would actually balance that distribution about there. And hopefully you can kind of visually see how that would balance there. If I put this balance point at 6, let's say I tried to balance it here at 6, what would happen to the distribution? It would go boop, right? It would fall down to the left because this is too heavy over here. So your mean is not always the middle of your x-axis. A lot of times, especially in a skewed distribution, you have to think about where it, what happens to it whenever you're averaging the values, okay? Does that make sense? All right, cool. We will go ahead and stop for now, and we'll finish these up first thing on Monday.